Hello friends, welcome to YouTube channel Crack Get Online. So in today's video I am going to discuss the design of contour bund. So when I say the design of contour bund, what do you mean by the design? So here, as I told you, the cross section of the contour bund is trapezoidal. So when I say design, so in design you have to calculate the base width, the top width and the height of the bund. That may be the H or D, whatever you say. So that is the height of the bund, and you have to decide in the designing the distance between the two contour bunds, the horizontal interval. Okay, so this all parameter is considered to be the design parameters. So let's move forward. So I discussed this numerical problem in last video where I told the top width is 1.5. so that is not 1.5, the top width is 0.5. okay, so kindly make one correction in the previous video. The top width is taken as 0.5. if nothing has been given, then this is used. You please remember this line. It will useful in your semester examination but not in gate examination, because in gate they will give the gate data. Okay, so let's move forward. It is one more practice question. So now you pause the video and read the question and solve by the yourself. I am giving you the hint that we have solved such same question previously, so you have to use this formula. Okay, so after using this formula, you have been given the horizontal interval and you have been given the slope, so you can calculate the vi in meter, and the rainfall is given as 80, so you put it in here in meter. So you will get the height of water impounding. So just see this picture. So this is the bund. What if I am taking one cross section? Okay, so let me take one cross section. Okay, so this, suppose this is the cross section. It is not typical bund cross section. So here this is the cross section. Okay, so after calculating h, what we calculate this side. Okay, this side we calculate. So this is the height of water that has to be retained behind the bund. Okay, this h is the retention height. This much height of water you want to retain. And what is given in the question? The depth of water over the weir, means this is the weir and the depth of water is here 30 centimeter. So h you are calculating and 30 centimeter water is flowing above this, and you need some freeboard, means height of bund will be not equal to this height, so you need some extra spacing. This extra spacing is called as the freeboard, and that freeboard is taken as 25% of the h, means impounding water side. So what will be your answer? Your answer will be, so 25% here. Now you have to take h plus 25% of h plus 30 centimeter. So that will be your answer. So you calculate and kindly comment in the comment section what is the total height of the bund. That height is known as the total height. Okay, so I think it is clear what is the difference between the total height and the impounding height, and if the water flow over the weir is given, then how you will calculate this. Okay, so let's move forward into the design of the contour bund. So as I told you, in contour bund you need to calculate the dimension of the bund. So here it is base width, top width and the total height. This is known as the side slope. And what is the use of side slope? Side slope is different for different kind of soils. So side slope determines the stability of this bund. So if this is the side of this bund, so here this interval, this slope of this side will decide whether it will remain stable or not. Suppose it is clay soil, so clay soil is more stable, so you can take this side slope as 1:1. Okay, 1:1 means it is always shown in horizontal raised to vertical, means this horizontal is also 1 and this vertical is also 1, so it is kind of steep slope. Now if this soil is sandy soil, means there is less chances of stability. Sandy soil is not that cohesive, so your slope will increase, means it will become 2:1, means horizontal height is higher and vertical height is lower, so it is 2 raised to 1. Okay, and what if it is in between loamy soil, then that will become half raised to 1. So this table you have to remember for clay, sandy and loam. I told you what is the reason behind keeping this 2 and what is the reason behind this one. If you will read by concept, you will not forget it. Okay, so side slope is dependent on the nature of the soil. How is your soil, how cohesive it is, so that you can make that slope steep or gentle. So one factor is this one. Then another factor, it depends on the rainfall, land slope and the soil texture. Okay, so you need a stable side slope based on the soil type. I explained you earlier. And while designing contour bund, how you will take rainfall into consideration, I told you what is the 24-hour rainfall. That height is 2 into RE into VI. So this RE is nothing but your rainfall parameter. Okay, and this VI is what? This VI is dependent on the slope. So here it is coming your land slope parameter. So all the things which you have used in the calculation of different technical parameters, that all depends on the designing parameters. So from this formula you can write this down in theoretical terms. Okay, so you need base width, top width and bund height. How you will calculate, I will show through one numerical example, but for now you remember this one. Okay, so now you calculated the individual dimension for this bund. So now you need the dimension for overall dimension. Overall dimension means what will be the spacing between two bunds, what will be the vertical spacing. Okay, so this HI and WI is known as the horizontal and vertical spacing. So that will give you the distance between two bunds. So first you need to calculate what will be the size of bund, and then you need to know what will be the spacing between them. Then only you can start constructing bund into the field. And the bund height, so I told you the formula, that under root 2 REHI, where RE is 24-hour excess rainfall or the rainfall for 10 year recurrence interval. So that is written here. And as in previous example, I told you, you need to take the freeboard as 25%. Okay, so that is the freeboard, because that height, whatever height you calculate, that is height for impounding the water. Means this much height of water you are already going to store, so your total height should be higher than this one. Okay, so it is basic understanding. And how to calculate the earthwork, how to calculate the area lost, that I have dealt in the previous video. You can see there. So here one question you see. So here it is showing, explain different types of engineering measures of soil erosion control. So that is the gully control structure, rail control structure, whatever you have read in your basics, that will come here. So the second part is design criteria for the contour bund. Is contour bund is soil erosion control instrument? Yes, so it will also come here. It is also engineering measures. Okay, your spillway will come here, engineering measures. Types of spillway will come here. Your net system, netting will come here. Your wind belt and shelter belt will come here. Okay, your bunding will come here, your terracing will come here. So all these are the engineering measures. And in second part is asking what is the design criteria. So whatever I told you in this video, that is not the design criteria. Okay, what was there? It was how you will design. So okay, that was the designing method, not the criteria. In this question it is asking what criteria you will use for deciding the vertical interval, what criteria you will use for deciding the horizontal interval. Okay, it is not asking how you will calculate, it is asking what criteria you will use. So this I think I have discussed in lecture 1.2 of this bund series. So here I have given the design criteria for bund. It is same for the contour bund or for graded one. So for bund in general we use this criteria, we use the seepage criteria. What is the seepage? So suppose this is here, it is the water impounding. So this D is the water impounding depth. Okay, so it is the, if land slope is 5%, so this will become 100 by 5 into D times. This will be one triangle. So here it will be one triangle, you consider is as one triangle, and here it is second triangle. So this is the amount of water, surface area of water that it has to impounded. And this is the seepage line. Seepage line shows that if water is impounding here and this is your material, this is constructed of the soil, so water will seep down here. Okay, so basically water will infiltrate through this side and it will travel through this. So the soil below this line will be wet soil, and the seepage line must pass through the this toe point of the opposite side. Okay, so this is the basic design criteria, and this much soil will be your wet soil. So suppose if you know the slope of the seepage line, you know this. Okay, so slope will be given in terms of depth, because this is D, then this height will be also D, and that will become, suppose seepage line slope is 5:1, then it will become 5D, and you know the side slope of this side of trapezoidal, then it will become, if suppose it is 1.5:1, then it will become 1.5D. Okay, this length. So total height, you add the freeboard, it will become total height. So if you will subtract these two sides, these two total, okay, this one 1.5 times total height or 1.5 times total height this time, then it will come top height. So this is how you calculate bottom width, top width, total depth. Okay, so I will solve one numerical question. From there you will come to know what is the, how you need to calculate. So this is the design criteria. So in the next video we will solve one or two numerical problems of the contour bund, then the bund and the contour bund series will be over, and we will go for the graded bunds. Okay, thank you for watching this video. Have a nice day.